Hello, Integrated Math 1. Welcome to Module 2, Topic 1, Lesson 4. We're doing the first half of this lesson today. We'll do the other half of this lesson next time. So we're going to focus on activities 4.1 and 4.2 for the time being. We have played with slopes of parallel lines before in an earlier lesson, and now we're going to start looking at slopes of perpendicular lines. So recall that perpendicular lines or line segments, they form a right angle. That perpendicular lines or line segments that form a right angle at the point of intersection. So I could bust out a protractor and I could measure that, and I'm like, that is a 90-degree angle. And if you see that 90 degrees, that right angle, then you know those lines are perpendicular. But you also know it has to be exactly 90 degrees. 91 degrees, no good. 92 degrees, no good. It has to be a perfect right angle, 90 degrees exactly, in order to be perpendicular. So I have for you a couple of graphs. We're on page M263 if you're not sure where we've gone off to. So I would like you to consider the three graphs shown. Each shows a line and its rotation 90 degrees about a point, which is also the point of intersection. So line A has been rotated 90 degrees around to get a prime, and there's our point of intersection right there on the origin. B has also been rotated around 90 degrees. We rotated it 90 degrees, and whether you think of it as up or down, either way works, but it's been rotated 90 degrees around this point right here on the y-intercept at 5. And this point, here we have line C, which has also been rotated exactly 90 degrees around this point right here at 6, 5. So taking a look at these lovely three lines, they've all been rotated 90 degrees. So I would like for you to answer for me real quick. Question number 1, are the lines in each graph perpendicular? And explain your reasoning. Hit pause, jot down your thoughts, and hit play when you're ready to check your work. So 90 degrees, well, if it's rotated 90 degrees, if that creates a 90-degree angle, sorry about that. If that creates a 90-degree angle, then that does mean, wasn't that exciting? You gotta watch your math teacher sneeze. If that creates a 90-degree angle, then yes, these are totally perpendicular. Yes, they're perpendicular. Each line is rotated 90 degrees. So the angle formed at the intersection of our lines measures 90 degrees, which is a right angle. And when two lines form right angles, they are perpendicular. Yes, these guys are totally perpendicular. Of course they are. You're not surprised by this at all. Not at all. So what I would now like you to do, and this is where we get a little more challenging, is I would like you to write the equation for each line, y equals mx plus b, all that good stuff. Write an equation for each line, the original and the transformed one for all three graphs. Remember that if you use y equals mx plus b, then you just need to know the slope, your rise over run, and your y-intercept, and boom, you can totally write the equations for these guys. So go ahead, take some time, write down the equations for all 6 lines, 2 on each graph, and then hit pause to write those out, hit play when you're ready to check your work. So I'm going to start with this first graph here. I'm going to start with my original line, line A. We said that I needed, if I have the whole y equals mx plus b, that I need the slope and I need the y-intercept, and I should be good to go. Well, for my slope, I can just pick 2 points, pick this point, pick this point. Remember, it's rise over run. So it looks like I went up 1, over 1. So my slope is 1. That's great. And of course, our y-intercept is all the way down here at 0. Ooh, dear. Wow. Why? Because it's a jerk sometimes. So this means that my y-intercept is, of course, 0. So I have y equals 1x plus 0. But that looks really weird. I don't usually write plus 0 on things, and I certainly don't need the 1 out in front. 1x is just x. So I just said that line A is y equals x. Let's do the same thing for this other guy, for our A prime. So again, I'm going to pick 2 points. Ooh, I'm not going up this time though. I'm going down. So I have to go down 1 over 1. So it looks like my slope is -1 over 1, also known as -1. My y-intercept, same spot. My y-intercept is at 0. So it looks like I have y equals -1x plus 0. But again, that looks a little weird. I don't really need the plus 0 on the end. And instead of -1x, I can just write that as -x. So for line A prime, I'm writing it as y equals -x. For the next graph, let's start with B. Again, I just need a slope and a y-intercept. So I'm going to start with a slope. Looks like I've got a point here, and I've got a point here. So it looks like I have to go up 1, up 1, and over 3. So it looks like my slope is up 1 over 3. So my slope is 1/3. My y-intercept, what is my y-intercept? Right there. There it is. So it looks like my y-intercept is 5. So it looks like my equation for line B is y equals 1/3 x plus 5. Let's do the same thing for B prime, shall we? So if we're looking at B prime, again, I'm going to pick 2 points. This looks like a good point, and this point here. So in this case, I'm going down. So I had to go down 3 and over 1. Over 1. So it looks like here my slope is now down 3 over 1, which I could just write that as -3. And of course, my y-intercept is the same place. My y-intercept is still at 5. So that means my equation for B prime should be y equals -3x plus 5. I just put in my slope, put in my y-intercept. Sweet. One more, two more, because there's 2 more lines. One more graph, 2 more lines. So for C, again, I'm going to pick 2 points. What have we got here? Here's a good point. I'm going to pick that one. And this one, that looks good. Yeah, I'm going to pick this point and this point. So for C, it looks like I had to go down 2 over 3. So that means down 2 over 3. I can't simplify that, so I'll leave it. My y-intercept is all the way up here. So B equals, what is that, a 9? So that means my equation for line C should be y equals, oh, Miss Scott can't type right. Hang on, I can do this. We did it right. I typed it wrong. I can fix that though, because I'm a smart girl every now and then. Yeah, I can fix that. I can fix it. Just give me a sec. I'm not very fast at fixing things, but I can fix things. And that means I gotta fix that too, so I can do that. And there we go, that makes things better. Sorry about that. That's okay. That means that line C, it looks like for line C, I have, and that says a B on it. That shouldn't say B, that should say C, shouldn't it? I'm gonna fix that too. That means I gotta fix this one. Oh my gosh, so many mistakes. It's like you're watching it live. It's all good, it's all good. So that means that for this, for line C, I have y equals -2/3 x plus 9. We did do it right, I just had it typed wrong, sorry about that. Let's look at line C prime though, and we'll do the same thing. I'm gonna pick 2 points. Here's a point, that looks good. Here's another point, that looks good. And I had to go up 3 over 2. So that means in this case, my slope is gonna be up 3 over 2. Looks like my y-intercept here is at 4, or pardon me, at a -4, isn't it? Oh my goodness. So that means for line C prime, my equation is y equals 3/2 x minus 4. Let's take a close look though at these slopes. Are you noticing something? So you just wrote all these equations for all of these lines. Are you noticing something about these slopes? Particularly like A to A prime, B to B prime, C to C prime. Are you noticing something interesting about the slopes? I hope you are, because that is the point of today's lesson. I hope you noticed that when you looked at our slopes, that when 2 lines are perpendicular, their slopes are negative reciprocals. Did you catch that? Did you notice that? that they were negative reciprocals, that you had to flip it and change the sign. So if one was increasing, the other one had to be decreasing, or if one was decreasing, the other one had to be increasing. And also that because our rise and our run switched when we did that shift, it flipped our slope, didn't it? So you have to change the sign and flip it. They are referring to them as negative reciprocals. I like to refer to slopes of perpendicular lines as opposite reciprocals, but you get the idea. And we can prove this. There's a lovely little theorem that we have here that proves it, that we can use this graph and proof to shown to analyze the validity of the theorem, to show that this is true, that for perpendicular lines, our slopes are negative reciprocals. So I'm given two lines. I'm given line P here and line Q. So line P and line Q, hey, these bad boys are perpendicular. Yay, they make a right angle. And I don't know what this point is, but I'm just going to call this point AB. We'll call it point R, and we'll say it went over A and up B in order to get there. And we're going to call M sub 1 the slope of line P. We're going to call it this guy's slope. And we're going to call M sub 2 the slope of line Q. We're going to say that's this guy's slope. And R is on the line here, which we're going to call AB. So if we rotate P counterclockwise with our origin as our center of rotation, and we go, woo, we rotate it 90 degrees onto Q. That was the point. Since P and Q are perpendicular, the image will lie on line of point R will be point D, and it's going to be on line Q under this rotation. Now, if you remember when we were playing with rotations in our getting started activity before we started this lesson, before you started this video, you remember that what happened with our coordinates, if this was A, B, do you remember what happened with our coordinates? That A and B had to switch, and that this front guy became the opposite. So A now becomes, so our x-axis, now x coordinate, I can say now becomes our y coordinate, and our y coordinate now becomes an opposite x coordinate. That's what it does. So since this rotation maps our positive x-axis into our positive y-axis, and it maps our positive y-axis to the negative x-axis, here's what happens. So we went from AB to negative BA, right? That's what happened. Went from AB to negative BA. So graphically, we can see how they moved, right? A was here and now it's here. So positive, but now instead of X, it's now Y. B was going up, but now B is going to the left, and so now it's negative, and now it's our X coordinate. So this graph shows the slope of line P as M sub 1. That means our slope for this guy is rise over run, so that would be B over A. All right, but that means the slope of this guy, if this is B over A, rise over run, that means for the second line, our slope is going to be rise A over run, which is now a negative B. So the slope of our first line, oops, sorry about that. Let me put us back where we were. That means the slope of our first line is B over A, but the slope of our second line is A over negative B. So take a look, sure enough, it got flipped and the sign got changed. That does create some interesting things. It does mean that if I take this guy, flip it, change the sign, so negative 1 over A over a negative B, 1 over A over negative B means I'm going to flip this guy to get negative B over A times a negative 1 makes it positive, and now they match. So this creates some interesting things. You may or may not care about them. By the way, this is what we call a paragraph proof. We proved something by writing a paragraph. In the future, you'll learn about different kinds of proofs and different ways to prove things. But also, this creates something interesting. This means if you were to multiply the slopes of perpendicular lines, you actually get a negative 1. True story. So this is super cool to notice. This is super important. I hope you highlight this, underline this, something like that. This is the big idea. We just proved it, which felt a little wordy, but this is the big idea. If two lines are perpendicular, then their slopes are negative reciprocals. It's wonderful. If you want to know what the slope of a perpendicular line is, fine. Flip it, change the sign. That's all you have to do. If it's positive, it becomes negative. If it's negative, it becomes positive. But you must do both. Please be careful of that. I have students that will remember to flip it, forget to change the sign. Or they'll remember to change the sign, forget to flip it. You've got to do both. So when you're asked to find the slope of a line that's perpendicular, you need to flip the slope, find the reciprocal of the slope, and change its sign. You have to do both. So with this in mind, I would like you to do question number 4 on page 65. You've got line J and line K, and they are perpendicular. So given the slope of line J, so these are all the slopes, these are all slopes for line J, I would like you to then find the slope for line K. Go ahead and hit pause to work these out. Hit play when you're ready to check your work. So remember what we just said? The moment I see perpendicular and slope, I'm like, hey, these guys are going to be opposite reciprocals. So opposite reciprocal it shall be. Actually, I think the book used, hang on, I think the book said negative reciprocal. So I'm going to use their wording because that's probably going to be better. So we said it's a negative reciprocal. So we got to change the sign and flip it. So fine, let's do this. So for this first guy here, part A, 2 over 3 is the original slope. So I got to flip it. That makes it 3 over 2. And I have to change the sign. Since this guy is positive, my new slope should be negative. So my new slope for line K will be negative 3 over 2. Same idea here, negative reciprocal. So I'm going to flip this. That's the reciprocal part. So instead of 4 over 5, it's going to become 5 over 4. But it is a negative, and I got to change the sign. So that means for my perpendicular guy, it will be positive. So my new slope is positive 5 over 4. This lovely guy right here on C, negative 3, I guess I should put it over 1 because that'll definitely make it easier to find the reciprocal, won't it? So I'm going to flip that. Instead of 3 over 1, it's going to become 1 over 3 if it needs to be perpendicular. And since that is a negative, if it's going to be perpendicular, my new guy has to be positive. So my new slope is a positive 1/3. So it's pretty easy to do, isn't it? Pretty easy to find the slope of a perpendicular line. You just have to flip it, change the sign. That's it. That's all you have to do to find slopes for perpendicular lines. It's a pretty cool trick. I highly recommend it. So you're definitely going to want to remember this negative reciprocal trick whenever you're dealing with perpendicular slopes. It's going to be super useful not only today, not only in your homework tonight, but it also is going to be useful in the next lesson and on your test. Here's my not so subtle hint for all y'all. All right. So I would like you to consider this lovely graph shown. We're going to activity 4.2. I would like you to do a few things with this graph. Just to start, you're going to want some kind of like a straight edge or a ruler, the side of a book or something like that. Shoot, maybe even the side of your cell phone. But you're going to extend these out. So starting with GK, I just want you to extend it all the way out, put arrows on either side, and we'll make it line P. I'll show you what I mean. So you might even want to use a different color just so it's easier to see. So I extended my line out, used a different color, used a straight edge to help me do it, / my computer, and created, and I'm going to name it line P. I would like you to keep going. I would like you to do this for GH, FJ, and KL and call them Q, R, and S. So go ahead and hit pause, extend out your lines and name them, and then hit play when you're ready to keep going. All right, so I extended them out. So GH, I stretched it out and I called that Q. FJ, extended that and I called it R. KL, I extended that and I called that S. So you can see I have 3 horizontal lines. Horizontal lines are the ones that lay flat. And then I have 1 vertical line here. And those are the lines that go straight up and down. Let's examine the slopes of these a little bit. And we've got some questions to help us do that. So consider the 3 horizontal lines. So Q, R, and S, these are our 3 horizontal lines, the ones that lay flat. And I got a question for you on this. For any of these horizontal lines, Q, R, or S, I don't care which one, pick one. If x increases by 1 unit, so I go from 8 to 9 or whatever it is, as x increases by 1 unit, by how many units does my y value change? Go ahead and hit pause, jot down your thoughts on that, keep it brief, and then hit play when you're ready to continue the discussion. So I don't know about you, but it didn't go up or down at all. So it doesn't matter how much x increased, 1 unit or 20 units. There was no change in my y value. No change at all. The value of y doesn't change. It did not move up or down. It was just flat as a pancake. Yes, it was. So describe the slope then. Since I had no rise and only a whole bunch of run, what's my slope? Describe your thoughts on that. Go ahead and hit pause, write down your thoughts, hit play when you're ready to keep the discussion going. So the slope of any horizontal line, guys, is 0. Because as the value of x increases, the value of y stays the same. So it doesn't matter how much x moves. There's no up or down happening there. And if you want to see it mathematically, like with numbers, might make a little more sense. I busted out my slope formula here. Difference in the y over difference in the x. And it doesn't matter how much the x changes. There's no difference in my y values, right? We just said the y values aren't changing. There's no difference. So that means it would be 0 on top. And 0 divided by anything is, 0. Yeah, because that's how that works. Definitely. So sure enough, anytime you got a flatliner there, looks like your poor line died, it has a slope of 0. Horizontal lines always have a slope of 0 because there's no difference in your y value. There's no difference in the y at all. And 0 divided by anything is, 0. So we have a 0 slope. You know what, though? Let's look at our vertical line. So we have our one vertical line here, line P. Isn't it pretty? Isn't that lovely? So consider the vertical line that we drew in question 1. Again, suppose that y now changes by 1 unit. Y increases by 1 unit. You can see I'm going up, most definitely. By how many units, though, does our x value change? Hit pause, write down your thoughts on that. Hit play when you're ready to keep the discussion going. Well, I hope you noticed that it didn't matter how much your y values went up. Your x values didn't change at all. The value of x did not change. There was no side-to-side movement, right? If we're dealing with that vertical line, it's just going up and down. There's no side-to-side movement on that. So the value of x does not change. So how does this help you describe the slope of any vertical line? Go ahead and hit pause, write down your thoughts on that, and then hit play when you're ready to keep the discussion going. So our horizontal lines had no slope, right? Because slope describes steepness, and horizontal lines had no slope at all. There was no steepness to it. It was flat. That's kind of hiking I like to do. But our vertical line is now so steep. It's so steep. There's no side-to-side movement at all. It's like if I were trying to hike up a cliff. And I don't do cliffs, and I certainly don't want to be hiking down a cliff. That feels like a bad idea. Our line has become so steep that it's undefined. The slope of any vertical line is undefined because as the value of y increases, the value of x stays the same. And again, I can show you with numbers, show you mathematically. So again, I'm going to bust out my slope formula here. It's a good little formula. And now we're seeing that there's no change in the x, right? There's no difference in the x values because the x values stay the same. So that means that would be 0. And you guys know, are we allowed to divide by 0? The answer to that is no. If you grab a calculator and try to divide by 0, it gets all like, error, and it gets all mad and angry at you, all that stuff. Yeah, so it's undefined. We're not allowed to divide by 0. It's undefined. Fair enough. So horizontal lines are so flat that they have no slope. They have a 0 slope. And vertical lines are so steep that their slope is undefined. That's rough. Let's go to question number 6 then. And I just want you to determine whether each of the given statements is always true, sometimes true, or never true, and tell me why. So A and B, all vertical lines are parallel, and I believe B says that all horizontal lines are parallel. Go ahead and hit pause, jot down your answers to A and B, and then hit play when you're ready to check your work. All vertical lines are parallel. That is always true. It's always true. The slopes of all vertical lines are undefined. We just said all these guys have a slope that's undefined. And so thus, they're all the same. Vertical lines all have the same slope of being undefined. So all vertical lines are parallel. It's always true. All horizontal lines are parallel. Always true. Because again, we know horizontal lines, slopes of all horizontal lines are 0, and thus they all have the same slope. Since they all have the same slope, they must be parallel to each other. Ooh, that says vertical. Naughty, Miss Scott, I'll fix it. You guys have watched all my mistakes today. Man, hang on, I'm gonna fix it. Horizontal. Oops, that's not the button. Okay, that's better. So yeah, the slopes of all horizontal lines are 0 and therefore the same. So that means all horizontal lines are parallel. Wow. So we now know that parallel lines all have the same slope. And we now know that perpendicular lines, their slopes are negative reciprocals. Okay. So with this in mind, can you do me a favor and describe to me the relationship between any vertical line and any horizontal line? Hit pause. How are these guys related, vertical lines and horizontal lines? And then hit play when you're ready to check your work. I hope you realized, guys, any vertical line and any horizontal line are always going to be perpendicular to each other. That's just how this goes. It is just how this goes. So I'm going to mess with you a little bit. I would like you to write an equation for a horizontal line and an equation for a vertical line that passes through the point 2, -1. I will tell you, it'll probably be easier to do if you make a little graph of it. It might be easier to figure out your horizontal line and your vertical line. So go ahead and hit pause to work this out and then hit play when you're ready to check your work. So as I said, it may help to do a little graph. So I'm going to do a little graph. I'm actually going to use a black pen to help me. So I'm going to make a little graph. Oh, that's not a good graph. I'm going to make a little graph. So I have to go 2 units to the right and 1 unit down. So it looks like my point is, boom, right there. There it is. Not my best point ever. Did you get the point? All right, so we're asked for 2 things here. I'm going to use 2 different colors to help me out. So we're asked for an equation for a horizontal line. So we'll start with a horizontal line that goes through this point. So a horizontal line that goes through this point. And it looks like it hits my y-axis at -1, which makes sense. That's the y-coordinate up here. So for my horizontal line, it hits y equals -1. So I'm going to say the equation for my horizontal line is y equals -1. Yay! It is a constant function, it's horizontal, it has a 0 slope, all that good stuff. But we are also asked, I'm going to use a slightly different color here. We are also asked to write an equation for a vertical line as well. So I'm going to write my vertical line. Again, it passes through this point. So I'm going to be like, go, little guy, go. Ooh, that's not a very good color, but we'll make it work. You can see that my vertical line hits my x-axis, doesn't it? And it hits my x-axis at 2, which again makes sense because 2 was the x-coordinate here. So it looks like for my vertical line, my equation is x equals 2 because it hits the x-axis at 2. Yay. Well, that's not so bad. Let's try this again. I have a slightly trickier one, but nothing we can't handle. I would like you to now write an equation for a line that is perpendicular to the line given by x equals 5. So it's perpendicular to x equals 5. And it passes through the point 1, 0. So go ahead and hit pause. Try this out. Again, it helps if you make a little ghetto graph. And then hit play when you're ready to check your work. I made a graph. Are you ready? I'm going to make a graph. I want my black pen back. So I'm going to make a graph. Here it is. I am given a few lines. I'm told that it goes through, that it's perpendicular to x equals 5. So 1, 2, 3, 4, 5. I'm going to use another color here to help me draw that. So 1, 2, 3, 4, 5. Oh, except it's x equals 5. Oh, Miss Scott, get it right. So 1, 2, 3, 4, 5. So that means it has to go through the x-axis because it does say x equals 5. So 1, 2, 3, 4, 5. That's where x equals 5 is right here. So I'm going to draw my line and be like, there you go, buddy. So there's my line. Oopsie. There's my line, x equals 5. So it needs to be perpendicular to that. So it looks like I'm looking for a horizontal line then, doesn't it? Since I got a vertical line, that's what they gave me. But I also told it passes through the point 1, 0. So over 1, and of course it hits at over 1 and up 0. So that makes it to this point right here. Oh, so if it needs to be, and I'm going to grab another color, if it needs to be perpendicular to this guy, so it should be flat, but it needs to go through here, so it looks like my line needs to come right down the x-axis. And it hits my y-axis at 0, which makes sense because I have a 0 for my y-coordinate. So that means it's going to be a horizontal line at y equals 0. Graphing it does help. It really does help me see what's going on. It makes a big difference. I'd like you to try out one more, just one more. One more. It's the last one, I promise. Question number 10. Again, write an equation for a line that is perpendicular to the line given by y equals -2, and it passes through the point 5, 6. So go ahead, hit pause to work this out, hit play when you're ready to check your work. Are you ready? I'm ready. So draw my little graph, make it a little bigger because I got some bigger numbers going on. 1, 2, 3, 4, 5, 6, 7. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5. I probably could have fit more in there, but hey, we're going to work with what we got. That's fine. I was given a few things. So I was given the line y equals -2. So here's my y-axis and -2 is right there. So I need to draw y equals -2. So it looks like they gave me a horizontal line. I needed to be perpendicular to that. And it's supposed to pass through the point 5, 6. So 1, 2, 3, 4, 5. 1, 2, 3, 4, 5, 6. So right about there. This is not the best graph I've ever made, not the best point I've ever made. That's a terrible point. But did you get the point? I hope so. Oh, I want to use purple. I'm going to use purple for my answer. Yeah. Now it needs to be perpendicular to this guy, so it's got to be going up and down, and it has to go through that point. So I'm going to make it go through that point, which is not the best I've ever done. And you can see it hits your x-axis at 5, so that means the equation is x equals 5. You know, another way you could think of this, guys, without even having to graph it, is realize that if I'm perpendicular to y, then to a y equals, then I must be looking for an x equals. And if I'm looking for an x equals, I need to be looking at the x coordinate of the point, which is 5. So that is a faster way you could have done it instead of doing the whole big graph. But I like doing the graph because it helps me see what's going on. But that's just me. As always, guys, I hope you found this helpful. I hope you found this useful. If you've got questions or concerns, please either pop back into the Zoom meeting and ask them, or email me, or come see me during office hours. I hang out around this place a lot. And I'll see you soon. Bye.